Hi, I'm Ken Stafford. I'm a maths tutor. I'm just going to take you through the solutions to this sheet I made. This sheet is a compilation of all the reverse percentage questions that have come up on the GCSE so far on the papers that have been released. Just a thing to look at here on all of these sheets, and you can find the link to this sheet in the description if you'd like to have a look at it. Just to point out, it references where every question's from. The first three questions we're going to do are from foundation papers because of the F. The F stands for foundation, and the number in front stands for what paper it is. So for instance, because the first question is from paper 1, that's a non-calculator question. So when we do that, we shouldn't be using a calculator. All the other questions are higher questions. This is a topic that sort of overlaps the foundation and the higher paper. So even though these questions have come from the higher paper, it's still probably worth doing even if you're doing the foundation. Again, there's only one of them that you can do that requires you to not have a calculator to do it. So most of these questions we can use a calculator on. Let's get straight into question 1. So in a sale, the normal price of a book is reduced by 30%. So what's key with these questions, and you can do this bit if you want, is because it's been reduced by 30%, it's now 70% of what it was originally. So it's 70% that is equal to the £2.80. Okay, so that's really key. So 70% is equal to the £2.80. So to get back to the normal price, the original price, we want 100%. And to get there, we're going to find 10%. And this is what's different about this question, where a lot of people go wrong. Because we're starting at 70%, to find 10%, we no longer divide by 10. We're actually going to divide by 7, because it's 70% divided by 7 that gives us 10%. If you divide by 10, you'll get the wrong answer. So if we divide £2.80 by 7, and this is a non-calculator question, so you're expected to do it without a calculator, we get 40p. We should notice that 7 goes into 28 4 times, so it's 40p. So the original price of the book is going to be 10 times greater, because we times by 10% by 10 to get 100%, and we times 40p by 10, so the original price of the book was £4. And when you're doing these reverse percentage questions, you should kind of be expecting the original price to feel nicer than the reduced price. It often goes back to a nicer number than £2.80. If you ever want to check whether you've done it right, you can always think, right, let's take 30% off what I think the answer is. So in this case, it would be 10% would be 40p, 30% would be £1.20, and if you take that off £4, you do get £2.80. So you can always check whether you did it right by reducing it again. The second question here, we're told that 56 tuna sandwiches were sold, and that is 40% of the total number of sandwiches. So what we're going to do is say that 40% of the sandwiches is 56, and we want to figure out the total number of sandwiches sold. So again, we need to get back to 100%. And again, to do that, we're going to go to 10%, and we're going to divide by 4 this time, because there are 4 tens in 40, and we divide 56 by 4, giving us 14. So if 10% is 14, 100% would be 140. So there were 140 sandwiches sold in total. Of the 56 tuna sandwiches sold, 18 were sold on Friday. Write 18 as a percentage of 56. Well, what we need to do is write it as a fraction first. 18 out of 56. Now if we type this into our calculator, and this is a calculator question, and then convert it to a decimal. On most calculators, that involves pushing the SD button, unless you've got a newer calculator which doesn't have the SD button. As a decimal, that's 0.32143 to 5 decimal places. To get that as a percentage, we times by 100. So that's 32.1%. And to the nearest whole number, we're just going to say it's 32%. So 32% of the sandwiches were sold on Friday, which is what 18 out of 56 is as a percentage. The third question, the first part, is kind of a different topic, really. It's not a reverse percentage question, and that's with these sheets where they're from past paper questions. Certain parts don't really line up with what the topic of the sheet is. But while we're here, we might as well look at it. This is a bounds question, the first part. If the house is correct to two significant figures, meaning it was rounded in the second column, so the tens, thousands column, it could be as little as 155,000. That's the lower bound. And the greatest possible value of the house is 165,000. And that's how we do those. Part B, the value of Rita's house increased by 5%. Her house then had a value of 210,000. So if it's increased by 5%, it's gone from 100 to 105% of its value. So it's 105% that is equal to 210,000. We always want to get back to 100% on these questions. We have been going to 1% on this question, to 10%. On this question, we're going to go to 1%. To do that, we divide 105 by 105. Now, this is a calculator question, so that's quite doable. And when we divide that by 105, just realised I didn't add enough zeros there. 210,000 divided by 105 is 2,000. And then to get to 100%, because we're at 1%, we times by 100. 2,000 times 100 is 200,000. And we should always be expecting this sort of nicer answer than we started with. 200,000 feels like the right answer. It's gone from 200,000 to 210,000 when it increased by 5%. The fourth question here, again, this first part of the question isn't really a reverse percentage. This is a compound interest question. If the company was worth 50,000 in 2009 and increases by 2% each year, well, we need to know what the decimal multiplier is for 2%. So if something goes from 100% and increases by 2%, it becomes 102% of what it was before. As a decimal, that's 1.02. So if you times something by 1.02, it will increase it by 2%. Now we've got to do this for 8 years because it's from 2009 to 2017. So we're going to do 50,000 times 1.02 to the power of 8. And that is going to give us the value of the company 8 years later. And we get 58,582 pounds 97 pence, but it wanted it to the nearest hundred, so 58,600 pounds. The second part here, a different company had a value of 250,000 in 2009. In 6 years, the value increased to 325,000. So that's 250,000 times by our decimal multiplier. We don't know what that is. I'm not going to use X, I'm going to use Y because they're using X to represent the percentage. And that's Y to the power of 6 because it's 6 years. And we end up getting 325,000. What is Y then? Well, to start with, we make Y the subject, so we divide by 250,000. And that gives us y to the power of 6 as 1.3. To figure out what y is, we now need to do the sixth root of 1.3. And the sixth root of that is, so we now know that y is 1.04469. So we need to figure out what the percentage interest rate is. Well, this is 104.469%. So the interest rate is 4.5%. So that's what we should put as our answer. Fifth question here, we've got a boat that's depreciating in value by 15% a year. We know it's 15% because 0.85 is 85%. So that means if we keep multiplying by 0.85, the value of the boat's going down 15% a year. And we've got to figure out how many years until the boat is first less than 50% of its value. What we should just do here is try a few numbers. So if we try 4 years, 12,500 times 0.85 to the power of 4, the boat is worth £6,525 and 8 pence. Half of that value would be 6,250, so we haven't quite made it in 4 years. So it's probably going to get there in 5 years. So let's check that. Yeah, so the boat drops below half its value. So 5 years. What we could also have done is just done 0.85 to the power of 5, and we're looking for when that drops below a half. 0.85 to the power of 5 is 0.44, and when it was to the power of 4, 0.85 to the power of 4 was 0.522. So over half, which is why it took 5 years to drop below half its value. The second part of this question, Jack invests £5,500 for 1 year, and at the end of the year he pays tax on the interest at a rate of 40%, and after paying tax he gets £79.20. So if he's lost 40% of the interest and he gets £79.20, that £79.20 must be 60% of what he got overall in interest. So we're going to go to 10%, and then we're going to go to 100%. So you are allowed a calculator on this question, so there are quicker ways than dividing by 6 and timesing by 10. But I like to do it this way. So £79.20 divided by 6 means that 10% is £13.20. So 100% will be £132. So that's how much interest Jack got. Well, what was the percentage rate of interest? Well, if we do 132 divided by what he originally invested, we get 0.024. Timesing that by 100 gives us the interest rate. So he got 2.4% interest on his money to end up after tax getting £79.20. Question 6, similar to the last one in some ways. Sakira's got £3,550 in a savings account for 3 years, and for the first 2 years she gets 2.6% interest. So 100 plus 2.6 is 102.6, which as a decimal is 1.026. So we're going to multiply by 1.026 for the first 2 years, so to the power of 2, and she was paid R% interest for the third year. So if we need to figure out what this is as a decimal, so I'm just going to call it Y. And then at the end of the 3 years, she had £3,819.21. So what we can do is 3,550 times 1.026 squared. So we get 3,736.9998y equal to 3,819.21. And we can figure out what y is now by dividing by 3,736.9998. This is a calculator question. I'm just going to hold it in the calculator as that value. I'm just going to use the answer button, divide by the answer, and I get y as 1.021998. So what must the value of r be? Well, this is 102.199%. So the interest rate to one decimal place must be 2.2%. So that's going to be my answer. Question 7 here, a bit more like the reverse percentage questions we're used to. If he gets a 5% discount off the price, then he is paying 95% of its original price. So it's 95%, that's equal to 551. We can go to 1% and then to 100%. So you always divide by whatever percentage you've got to get to 1%. So we divide by 95. So we'll divide 551 by 95, which is 5.8. And then to get to 100%, we now times by 100. And 5.8 times 100 is £580. And we're expecting a nicer number than 551. Feels like the price it would have been originally. We can always check if we've done it right by finding 5% of this and taking it off, and we'll find we got the right answer. And on the end of this question is a compound interest rate question. So £6,000, getting 2.4% for the first year, so 1.024. That came from 100, add 2.4, which is 102.4%, and as a decimal is 1.024. For each extra year, Joan gets 1.7%, so the money increases by 101.7%, and the multiplier for that is 1.017. So the overall investment is for 3 years, so for the second and third year, I'll write it as out in full. It's that. Overall, that will give us the total amount of money Joan has at the end of 3 years. So we just type that into a calculator. And we get 6,354.67. So that's the value of Joan's investment after 3 years. Eighth question here, VAT, which is value-added tax. Tax is added to a lot of things that you buy in the UK, and it's called VAT. So whatever the washing machine was, there's 20% added. So that's with the VAT added. So 120% is equal to £600. If there was no VAT on, you'd only pay 100%. So we can go to 10%. It doesn't matter. We could go to 1% here. It always feels nicer to go to 10%. And actually, this is a non-calculator question. It's from paper 1, higher paper 1. So we would have to do this without a calculator. So we would have to do 600 divided by 12. What you might notice is that there are 5 12s in 60. So 10% would be 50, and then 100% would be 500, because we times by 10 to get to 100%. And £500 feels like the answer. And if we think about it, £500, if you had to add on 20%, 10% would be 50, 20% would be 100, which would get you back to the £600. So quite a nice, easy one, that. Question 9 here, 6,000 invested for 5 years. We don't know what the interest rate is, but we know it's compound. I always like to use y here for 5 years. So whatever that decimal multiplier is, we times 6,000 by it to the power of 5, and we're told the investment is worth £8,029.35. So to get y as the subject, we're going to first of all divide by 6,000, and that will tell us that y to the power of 5 is, and it comes out around 1.059. No, it doesn't. That's not right. Let me just do that on the calculator. 8,029.35 divided by 6,000 gives me 1.338225. And then to find y, I need to find the fifth root of that number. And the fifth root of that number, I'm just going to use the answer button on the calculator. That's what comes out at 1.05999. So the interest rate, it must be 6% because this is 106%. So the interest rate must be 6%. Question 10, similar to the last one. £12,000 invested. We don't know the interest rate in the first year. So we're going to call the decimal multiplier y again. And we know after the first year, Gina's got 12,336. So we can figure out y by dividing by 12,000. And that gives us 1.028. I think. Let's just double check I'm not ahead of myself. Yes, so y equals 1.028. So that is a 2.8% interest rate. Now we're told in the second year the interest rate halves. So to figure out how much Jean has after 2 years, we're going to times by 1.014, because that's 1.4%. It's half of 2.8%. And we're going to times the money she has after the first year, the 12,336, by 1.04, and we should end up with £12,508.70. So that's how much you'll have at the end of 2 years. Question 11 here is about a house that Jerry originally bought. We don't know how much he paid for the house. I'm going to call it Y. We know in 2007 he sold the house to Mia and he made a profit of 2%. 20%. So 100 plus 20% is 120% as a decimal 1.2. So we know that Mia bought the house for 1.2y. So 20% more than Jerry paid for it. And we know that Mia sold her house for 162,000 and she made a loss of 10%. So a loss of 10% would be 100 take away 10. So 90% of what she paid for it, or 0.9 of what she paid for it. So she paid 0.9 times 1.2y, and that was equal to 162,000. So that is the very complicated way we need to set it up. So if we do 0.9 times 1.2, we now know that 1.08 of y is 162,000. So to get y, which is what Jerry paid for it, we're going to divide 162,000 by 1.08. And we're expecting to get a nice number here. Often when you get back to the original, it's a nice number. And yes, it ends up being 150,000. Now, if this was me in an exam, I'd be tempted to put this back through. So if I'd start off with y being 150,000, I'd increase it by 20% to find out what Jerry sold it to Mia. And then I'd take 10% off that to see if it is 162,000. So if we do that down here, 150,000, what Jerry paid. He sold it to Mia for 20% more. 10% is 15,000, 20% is 30,000. So she paid 180,000 for it, and she lost 10%, so she lost 18,000, which is 162,000. So in checking that, we know that Jerry definitely paid 150,000 for this house, and we can feel confident giving that as our answer. It's nice to check like that in the exam to know that you've done it right. So final question on this sheet. We're told that Marie paid tax on her interest at a rate of 20% and that the tax she paid was £28.80. So what we can do is we can go up to 100% by timesing by 5, and we can find out exactly how much interest she earned. And 28.8 times 5 is £144. So Marie got £144 interest on her 8,000. So now if we divide the interest by what she had originally, we will get the interest rate as a decimal. So 0.018 as a percentage, we would times by 100 to get an interest rate of 1.8%. So that's the amount of interest she got on that account. And that's the last question. So the written solutions, the handwritten solutions I've been doing, can be downloaded as a PDF by clicking on the link in the description. You can also find the questions there as well. There's also a link to my website, which has more sheets like this. So ones I've put together on different topics, but also on the website, there's links to lots of different sheets like this from different websites. So really useful if you want to practice more questions like this. Thanks for watching.